Hi, everyone. This is Jane Zhu. I'm a senior software engineer from distributed storage in Bloomberg. And today, my colleague Krunal Chheda and we are going to talk about Ceph multi-site at scale, Bloomberg's disaster recovery journey. Basically, the story of how Bloomberg storage team adopted Ceph RGW multi-site feature. A brief agenda first. I'm going to start it with a brief introduction of who we are and what we are doing, and then have a quick look at how our Ceph clusters look like in Bloomberg. Then we go and deep dive into our multi-site journey, and we'll finish it with a touch on our future plans. And then at the end, we're taking questions. So who we are. Bloomberg is a financial technology firm founded in 1981, and we provide data services, news, analytics, and software to financial institutions. And we have more than 350,000 subscribers in 170 countries. And each day, we process more than 300 billion pieces of data from financial markets, with a peak of 10 million messages per second. And worldwide, we have more than 7,000 engineers. Both Krunal and I are from distributed storage team, which is part of storage engineering. And in storage engineering, we design, build, and maintain all those storage products for the entire Bloomberg engineering. And we support appliance-based storage as well as software-defined storage. In terms of storage types, we support file system, block devices, and object storage. And we also provide data protection, storage workflows, and automation. And in particular, our storage, a distributed storage team, we mainly focus on software-defined storage. And we provide support for block devices as well as S3 object store. And for the block storage, we mainly used in OpenStack. That's in collaboration with our compute engineering team. And object store, we call our product BCS, Bloomberg Cloud Storage. We are going to use this term throughout this presentation. And both our block storage and object storage are currently backed by Ceph. But in today's presentation, we mainly focused on our S3 object store. So let's have a quick look at Ceph clusters in our Bloomberg Cloud Storage, BCS. Because it's an object store, so it's heavily RGW focused, and we serve more than 1 billion S3 requests per day. And we have 4 clusters across 4 data centers. And all these clusters, we serve about 1,600 tenancies, and we have about 65 petabytes of raw data, raw storage capacity. And for each cluster, we have around 4,500 OSDs and more than 50,000 buckets. All these clusters across the 4 data centers are actually grouped into 2 products. One is our legacy BCS product, which doesn't have a multi-site feature. And of course, another one is our new clusters, which has this multi-site feature supported. Let's have a quick look at our legacy BCS clusters. We can see we have this is a high-level architecture. We can see we have like 2 data centers, and we have like a Ceph clusters installed on both of them. And here, those Ceph clusters installed on both data centers are totally independent. We don't have any cross-data center communication. And our clients, which are Bloomberg applications and the internal users, they connect to these 2 data centers independently using 2 different endpoints. With this architecture, we can clearly see some kind of drawbacks, especially under the threat of disasters. Like disasters do happen, and it did happen before, of course. And in case of disaster, our data center could be destroyed, and we have to think about disaster recovery. And So because the specialty of Bloomberg business, data and business continuity is crucial. So in Bloomberg, each and every product has to have a disaster recovery mechanism built in place. However, in our legacy architecture, because we don't have a cross-data center communication, so we are not able to provide server-side disaster recovery. In this case, we highly rely on our client side to do the job. So our clients have to replicate the data across data centers themselves. And in case of a disaster, for example, like a data center is flooded and destroyed, the data center is down. So our clients are responsible to switch their connection from the downed data center to a good one. So as from the storage platform provider point of view, this is really not good. This for a few reasons. First of all, it duplicates client-side costs. Because we are the storage platform provider, we cannot control how our users use us. In reality, our clients use a large variety of client-side tools, APIs, libraries to access us. They generate very different traffic patterns. This complexity makes it almost impossible to find one solution fits all. So when a client is onboarding us, they have to keep in mind that they have to build their own disaster recovery mechanism into their application. This extra cost actually hinder the adoption of our BCS as a product. Our clients might want to go to some similar products with those disaster recovery mechanisms supported. And also from the company as a whole point of view, it's a huge waste of resources. That is the client side. On server side, we have a different type of issue because we cannot control how our users use us. So it's totally up to them to decide if they want to replicate their data across data centers. So as time goes by, it's unavoidable that like some kind of a data imbalance will be generated. That will cause some issues, maintenance issues down the road. So just because of this, we know that we really need server-side disaster recovery. Actually, pretty much from the very beginning of our BCS product, server-side disaster recovery has always been the most wanted feature. But how can we achieve that? Could data backup and restore help us in this case? Data backup and restore is in the domain of data protection. And after some examination of the data protection, and we found out actually it's not the right tool for this job for a couple of reasons. The first one is that disaster recovery is supposed to for the entire cluster. However, not all data in the cluster is business critical. And we don't want to like back up and restore the entire cluster. We want to only back up and restore those critical ones. So the requirements don't match. And also data protection is a separate tool, runs on its own, runs on schedule, not on the object store transaction. So they are not even in the same rhythm. So we know that data protection is not our solution. Then here came the Ceph multi-site feature. It's an object gateway configuration. It can achieve data replication across data centers. And it provides asynchronous data replication, and it supports both active-active, active-passive settings. Those are all the features that we need here. So no struggles. And also, like, we don't have like any more choices anyway. So we know that multi-site is our solution here. So how the OSF classes will look like with this multi-site feature supported. This is the high-level architecture for new clusters. We can see it's very similar to our legacy ones with the major difference. The difference is like right now we do have a cross-data center communication. This communication for the data synchronization, we call it multi-site replication here. And our clients, they don't need to connect to individual data centers separately anymore. Right now, they are data center agnostic. They're only given one single endpoint. They use that to access their data store and leave all the rest to our backend servers. Okay, Now we have a feature to support. We have architecture in mind. We have classes ready. So the only thing left is to test, test, and test. We did a lot of tests, of course. And we actually started our proof of concept a very long time ago, but that was mainly in Nautilus. Nautilus, of course, has been end of life. So we had to move to like later versions. We tested the Pacific, Quincy, and main branch, later cut into Riff. And we did a lot of functional tests. We did a lot of performance and stress tests. And in the performance and stress tests, we're mainly using benchmarking tools, CostBench, and Warp. We did a lot of tests. With these tests, is replication working well? So the simple answer is no. Otherwise, we won't have today's presentation. So it did work well in Nautilus, though. But we cannot use Nautilus because Nautilus is end of life. Also, Nautilus is lacking some later features and some important bug fixes in multi-site. So we have to go to the post-Nautilus versions. And we did a lot of functional tests in the post-Nautilus versions. In all those versions, functional tests work well. But those functional tests only had very light load. They worked well. Things started going south when we went to a very heavy load. And we started noticing missing objects here and there. Basically, multi-site replication stopped working well in heavy load. But how did we detect this? Originally, we heavily rely on the sync status. But during our test, we found our sync status didn't always reflect our failures. That made us very suspicious. So even the sync status did reflect our failures, how could we trust it, right? Is it the problem of sync status itself, or is the problem in the multi-site replication workflow? So we developed our own homemade tool to verify the number of objects in different data centers, like after the workflow was done and the replication was supposed to be done. And of course, we found a lot of mismatch. In case of mismatch, this tool always print out the missing objects. This provided a lot of help in our later debugging process. So we verified there's a multi-site replication issue. But still, we are not very sure it's the issue in the replication workflow itself. It could be we did something very stupid in configuration. So we tested a lot of combinations of different configurations. And after those tests, we verified, okay, it's not the problem of the configuration. The problem was indeed in the multi-site replication workflow itself. That's when we decided to reach to the community. We opened the issue tracker, and we sent a problem in the mailing list. And after that, we started attending this RTW Bug Scrub weekly meeting to get the community's attention to us, also exchange information between us and developers. And after the meeting, we collaborated with the developers directly on testing, debugging, and suggesting fixes, and code review, etc. And with this, I'm going to pass to Krunal to talk about the details of how we collaborated with the community to debug and eventually fix the issue.
Good morning, everyone. Myself, Krunal Chheda. I work along with Jane in the BCS team, the Bloomberg Cloud Storage team, the distributed storage team. I joined kind of Bloomberg a year ago, so I didn't knew about Ceph before kind of joining Bloomberg, so pretty much my entire 1 year has been around Ceph. This is my first Ceph event, so it's pretty exciting. Looking forward to meet you all. So, continuing to talk about our journey. So, so far, you guys know that why multi-site was more important to us. It was a big hindrance for a lot of our Bloomberg clients to onboard BCS because it didn't have the DR1 functionality, which was provided by the multi-site. So this became really important for us to get this fixed as soon as possible because there was a commitment from our side where we were supposed to deliver the multi-site to us so that we could, so that our end users could onboard us. but this whole fiasco happened there where we realized the things are not working. And of course, so we did reach out to the community, but then it was not kind of, it didn't make sense kind of doing a wait and watch where we just kind of hold on to the ticket and then just keep asking people, kind of scanning through all the tickets and trying to figure out what the issue is. It was a perfect kind of scenario made for us where we start with Bloomberg's in-house Ceph development. So this was a classic use case for us to start, probably not a good way to start it, but it was kind of forced us to go into this in-house development of Ceph. So that's how it pretty much kind of started for us. So we just treated this more like a conventional programming problem where you have a problem and how about when you go about fixing this problem, the first thing you want to is to be able to reproduce it consistently. Once you're able to reproduce it consistently, you then kind of move on to kind of debug what the issue is, trying to find the root cause, fix it, and test it. So that's pretty much kind of flow was for us. And as a part of this flow, there were some lessons learned in our journey, and that's what I'm here to share about. So coming to the first step about our reproduction, right? So as Jane mentioned, right, this was happening under a heavy load, but then we didn't have kind of consistent pattern where we could reproduce this at a proper, like, oh, we know that these are the X, Y, Z steps that we do, and then we were able to replicate it. So our first focus was to be able to come up with a plan or come up with steps where we could reproduce this more consistently. But there was a big challenge or kind of problem for us was we had a lot of our specific configuration. And again, to be really honest here, we were just hoping that this should have been a config issue versus an actual multi-site workflow issue, so that we would have done something stupid. We would come back and then kind of just fix it and then didn't have to go and dig into the code and then try to fix this, right? So we wanted to make sure that it wasn't a config issue. So it led to a lot of configurations that we had to test whether the issue is config issue or actual code issue. And for that, we always relied on cost bench. And then on the cost bench, basically, we just set up number of users, try to mimic what our production load is in terms of number of users, every user, number of users, the amount of buckets that every user can create. And something, as I talked about, we do our configuration. I kind of remember yesterday somebody was asking, is there a way in multi-site where the RGWs we can isolate where one of the few RGWs or the few instances of RGWs are just doing the client traffic and the other instances of RGW is just doing the replication. So we do have that particular configuration. So we just wanted to make sure that this is not one of these, it's not the config issue and it's a code issue. So we have a lot of permutations and we had to test those. But the bottleneck was we only had one test cluster, so it didn't make really sense for us to go do this one test, get rid of the wipe out the cluster, purge the cluster, and then rebuild, and this would have taken forever. So that's when we had to think something else, and we kind of leveraged the BCC. As Jane pointed out, BCC is our sister team, which is the Bloomberg Cloud Compute team, which also, again, is block storage on Ceph, so which allows us or gives us the flexibility to spawn multiple VMs. So that basically became our control test bed, and of course, we also kind of developed our in-house CICD pipeline. So these two combinations allowed us to kind of, at will, deploy multiple Ceph clusters, and at will try to pick up we could pick up any upstream Ceph branch, build it locally, and then use that build locally Ceph and deploy it onto any one of our BCC cluster. So that became a classic control bed, test bed for us. And then, as we all know, right, divide and conquer is the best option. As I listed out, there were multiple permutations that we had to test out and figure out that this was not a config issue. So what we did is we pretty much kind of divided all of these combination across different team members, did a bunch of testing, and tried. At the end, we were able to have a consistent reproducer. And this reproducer, as it says here, it pretty much was like running a 10-minute smoke test, which was creating 30,000 buckets, and then a subsequent test where we would run the same workload for 4 hours, creating another 30,000 buckets, and then kind of bombarding the cluster. So that would pretty much kind of create more than close to 10 million objects across all of the 10 million the RGW objects in our cluster. And it took almost 4 hours for us to replicate. it sucked kind of having to replicate, taking so long to kind of figure out whether it's broken or no. But then at least it was something better than nothing. So we had a workaround where we know we are able to reproduce this, but it was just 4 hours. The important lesson about this journey was, I think in the keynote, there was kind of mentioned like, there has been efforts to kind of increase the way people can swiftly kind of deploy Ceph and use a custom build. So I can say that we in our in-house, because of our BCC and our Ceph CICD pipeline, it's a classic example where we could just pick up any branch, deploy Ceph, and then that deployment can span, like it could be a beefy setup where we want to do a multi-day testing and stuff like that. So that basically becomes our bread and butter for our future Ceph development. So that was our biggest takeaway from this particular exercise of reproducing it. And yes, to our bad news was this was not a config issue. This was actually a code issue. So we had to go and now kind of collaborate with the community to try to kind of find a fix on this particular problem. So now that we were able to reproduce it consistently, our next step was to try to figure out or debug this. How do we go about kind of figuring out what exactly is happening, right? Ceph being a distributed system, debugging distributed system is not pretty easy, not trivial. So you often rely on logs. So that's what we pretty much did. We turned on the debug logging across the entire RGW component. We turned on the debug 20, which pretty much kind of spans your entire cluster. Your pretty much your host gets full with, your disk gets full with the amount of logs that gets spit into with the debug mode. So that was one thing we learned, or probably something to look forward is it would be nicer from the developer point of view if there was a way to just turn on debugging at a file level versus a component level. Like there might be so much things, there are so many things that are going in the RGW, but then we were pretty much kind of interested only in the replication workflow. So it kind of, with so much of spam log, it kind of makes it difficult kind of to trace that things. So it would be nice to have a way where we could just turn on that debugging only for specific files. But coming back to our journey here. So what happened was eventually the tool that we had, which spits out what objects or buckets are missing, like what objects are missing from a bucket. We took one of those objects, kind of traced that journey of that particular object in the log file, and then we figured out there's something fishy between in the trace between that object versus an object that got replicated, and somehow we figured out that this seems to be an issue, and then we went ahead and kind of updated the tracker saying that this is what's happening. So now that we knew we are able to reproduce it, we knew there is some debugging issue, now was the time to kind of figure out what exactly was the root cause here. I'll try to be more kind of non-technical here and try to be more operational, but just kind of giving what exactly the issue was. So the way multi-site works, as you guys know, or probably people who don't know, it's more like a log-based thing where the primary cluster where goes and writes, it goes and updates the logs in the data log shards, and then the secondary keeps polling for those data, the data log shards on the primary, and tries to see if there's any new data that has been written, and then it just tries to copy, right? So the data log that's been written on the primary, they're stored in the FIFO base, right? So these are Rados objects, but they're stored in the FIFO format. Versus the regular OMAP format, which pretty much which being used for the data stuff. But this data log, the Rados object which is stored in under the data log shard, was changed from OMAP to FIFO in Pacific. So that kind of explains why this was working in Nautilus, and then it stopped working in Pacific. So again, coming to give you just like a brief overview how this works is. An end user would go and put an object into a bucket, and there would be a corresponding entry to in the bucket index, the by log shard, the bucket index log shard, and the entry of that bucket index goes and maps to the data log. And in the data log, the data is then stored in the form of FIFO, where you have multiple objects which are like a linked list stored there, and each object is basically a 4 meg object. So what happens is each of these 4 meg objects stored has an entry for corresponding bucket log. So if I write a bucket, I write an object to a bucket, it gets maps to one of those bucket index log shard, and that bucket index log shard eventually gets mapped to one of these 128 data log shards. And then the data is stored across these in the FIFO format. what happens is these FIFO objects or Radar's FIFO objects are 4 meg. So in the event when this object gets full, the workflow inside the multi-site goes and tries to create a new object. So this was a classic problem of a race condition. This whole process of creating new object was kind of non-atomic. So basically what happens is, let's assume like there are 2 objects that have been written to buckets, and both bucket kind of map to the same data log shard. And then both those threads come and realize, okay, the FIFO object underneath is full, I need to go and create a new object. So what's happening was both those threads went ahead and created 2 new FIFO Radar's object. And what happened was one of them is marked as head and the other becomes an orphan. So the one which was remaining orphan, whatever entries were there in that particular FIFO object was never synced across the secondary side, right? So that was the root cause of this issue. This basically just, we kind of figured out based on looking at all of those logs. And while we were trying to compare the sizes, we saw all of the size of all the Radar's object under that particular shard were 4 meg, except one of those objects which was not 4 meg. So basically, any biolog entry which is under that particular object was never synced onto the secondary side. So that basically was the root cause of this issue. Now that we knew the root cause, right? So there was always this pain point where we were not able to replicate this pretty quickly, right? So we almost took 4 hours to replicate it. So what we thought was, we try to focus our energy in the 2 directions. One direction was obviously to try to get this fix and update the tracker and try to collaborate with the developers outside and try to get the fix. But at the same time, it would have been nicer to verify, since I said that we have a CICD pipeline and the BCC where we can spawn multiple clusters, it would be nicer to just spawn a cluster, I can do any of my changes, try to test out those changes and see whether it's working. It wasn't a great experience kind of waiting for 4 hours to figure out whether the fix is working. So we focused our next set of energy on trying to get this, reproduce it more quickly. So we basically kind of try to enforce this race condition more aggressively. So what we did is, as I mentioned, that default size of that FIFO object was 4 meg. So we trimmed it down to 1 meg. So basically what happens is every time you write a heavy load, the FIFO object gets filled faster, so that there will be a contention for it to, for the Radar's gateway threads to go and create a new object. And at the same time, instead of default 128 data log shards, we try to shrink that to 32, so that more buckets would then more objects would then try to map to the same data log shard, and then they would go and try to update the same FIFO object underneath, and then this would kind of aggressively create that race around condition. And to our happiness, we were able to reduce this from 4 hours to less than 30 minutes, basically. Almost, if I can recollect, it was almost like somewhere between 10 to 20 minutes is where this issue would get triggered versus getting triggered at waiting for 4 hours. Just that we did these changes in the code level, and then we used to, sorry. We did this changes inside the code and then kind of locally build the code and then deploy that particular Ceph package and do the testing. So that was our basically the view look like. So then what happened was, of course, there was a PR there in the open world, and we were like kind of actively providing comments on those PRs, as well as we also opened our kind of PRs there, which kind of more kind of classic collaboration where things which were nicer in both PRs were kind of merging together. So that's after a few iterations, we eventually were able to reach out to a solution where things were working fine. So now everything's in place. We found the root cause, we've done the testing. What next? So the next thing was to now take up here and then continue to the in-house Bloomberg journey of now kind of deploying the Ceph multi-site cluster. So again, in our today's keynote, there was kind of mention saying that there was a lot of improvement which went across the multi-site for the Reef release. So this was again more like a collaboration where there already was a branch in the open source world. where the multi-site fixes were being pushed in, but they were not merged onto the main. So we kind of leveraged, we took up that particular branch, mixed and patched this PR, and then pretty much took this whole PR, mixed it into our CICD pipeline, deployed our Ceph cluster, and did our testing pretty much for almost like, I would say, a week. We ran this workload not for 4 hours, not for 8 hours, but we continued this whole workload for a whole 1 week. And just this whole purpose was to figure out whether the functionality is working or no. Of course, there would have been other issues, but for us, more important was whether the functionality, when I create an object on the primary, it should get replicated to secondary, was our main focus of testing. And we were able to successfully verify that in the 1 week of testing. So basically what we thought was, with the reef getting postponed, let's not wait for reef, just pick up this particular branch, which is more like alpha version of reef. And yeah, to everybody's surprise, this our production world is using a non-GA branch. It's kind of main branch. Alpha branch of reef is what is today used for our multi-site cluster. In this journey, there were two pressing issues that we kind of felt needs to be addressed going down the line. One of them is this monitoring dashboard for replication. Again, during the developers summit yesterday, there were a lot of complaints about the dashboard being more on the focus on the OSDs and the managers and the mon side. It's much lesser on the user side or the RGW side. So this is a classic example where the Ceph does not has any way to spit out saying that, okay, all the objects which have been written to the primary are being synced to the secondary. So that's the biggest kind of drawback. We did develop a tool, but that tool is basically you run that every now and then, get the bucket counts, then run the bucket stats, and then kind of run the jQuery and then get the counts. It's not a pleasant experience. So it would be nice to have some kind of dashboard which kind of reflects what number of objects that are kind of missing, are still yet to be, not missing, but they're still yet to be pending replication. So that was one of the issue, and we are working on a system where we could be able to do that. And of course, the second issue, again, this was again kind of pointed out in one of the comments yesterday about the replication lag issue, the fairness issue, which has still been working on. Hopefully that gets merged into the reef, or worst case, we're just hoping to more collaborate on that, where we could leverage the Bloomberg's testing capabilities, where we have our BCC and CICD pipeline. We could patch in that PR and try to do rigorous testing and kind of provide more inputs in that. So looking forward to that things. So yep, that's pretty much talking about our journey of multi-site. Just want to take this moment to thank the community for getting us, helping us get this issue fixed. And finally, just wanted to throw this out here. Anybody interested at Bloomberg doing any work, please feel to reach out to our booth. We are actively hiring. Thank you. Yeah, we are open to questions if you have any. Sure. So we've been using the traditional one where we have one realm and then we have two zones. Basically, that's our setup today. And that's the setup that we've been trying to set, where our one zone represents one of the data center, the other zone represents the other data center. And that's what our workflow, that's how our testing has been. Yeah. No, so yeah, for us, that was not the use case. For us, the use case was more about replication across for all users and all buckets, yes. So we never explored these options. Yes, the Ceph does provide you this customization where it allows you to select specific buckets which you want to replicate across which zone. We don't go into nitty-gritty details. For us, it's much more a vanilla case where everything that gets written to one side that needs to be replicated to the other side. Sure. Mm-hmm. But if he puts an object, and immediately after it gets the object and is accidentally redirected to the secondary zone, it may get a 404. Yep. Pretty much confusing. So yeah, we can definitely discuss about this for sure. Yeah. Yeah. Sure. Yeah.
So eventually we're gonna convert to the main branch because that feature branch, multi-site feature branch has already been merged to main, and pretty much like a next version will go with the probably Reef. But it depends. It depends if we have like more issues and we have like separate fixes or not. But we are hiding that way. We want to keep up with the GA build. Like for example, next will be the Reef.
Just on to add on to this is probably at Bloomberg, first is we don't intend to have our own repository. It's more like we're just going to pull in from the upstream and then try to merge it. So it's not that we're going to have our own code base and then try to patch in. But the idea here is, yes, it's more like a alpha version of Reef where the multi-site fixes that went into the Reef, we just based our branch out of it and then eventually. So we are basically at this point in time just waiting for the fairness issue to be kind of getting merged in. And that would be basically our next kind of upgrade plan is what, that's kind of in pipeline for us, yeah.
Are there any plans to open source your CICD pipeline to actually build Ceph like in the way you do? Do you think it would make sense to have other organizations use your workflow to speed up testing in other organizations?
If there's interest, of course, we can always like open source. Or we already decided to open source for some of our other like Ceph project-related tools. But of course, yeah, we can consider the open source or CICD pipeline as well.
What I didn't see from your talk was how much did you have to deploy? Sorry, I got the microphone. How much test environment did you have to deploy to get to the point where you saw the bug appear? I mean, were you like close to production size, or was it, like at what scale did the bug emerge?
So as I said, right, like we were able to in our original configuration, out of the box configuration of Ceph, we were able to only get this reproduce after 4 hours, where we are creating 30,000 buckets for the first sanity and then another 30,000 runs. To kind of sum it up, it was not exactly total production load, but it was our daily production load where every day we intercept like 1 billion requests. But those billion requests are not necessarily all of them are write requests. But to just put in numbers, we were creating almost close to 15 users, and those users were creating 60,000 buckets and then our objects. So at the end, total RGW objects would be in somewhere in 10 millions is what, when this issue would kind of propagate.
So I guess my question is more, you deployed it somewhere, right? And
yeah,
I mean, and how close to that hardware that you deployed it on, how close was that to your production scale? Was it, I mean, did you have one single Redis gateway with 3 OSDs, or was it like, yeah?
Yeah, thanks for bringing out that. Actually, I had that mentioned. I kind of forgot that. So our original plan was the way we wanted to deploy. So this was not exactly one-on-one mapping to what our physical clusters are. It was more on the VMs. But those VMs we have a way to configure them. Those VMs like in the amount of RAM and CPU that we need to allocate that. So in terms of numbers, we were running with 2 RGW hosts each of them running 2 instances, so that brings into 4 instances of RGW. And then we were having 4 OSDs in the background, and then we have 3 mons and managers. So that was our basic setup for while testing. Our physical is actually is way much bigger than that.
Yeah, sure. That's thanks. Yeah, that answers my question. Thank you very much.
You mentioned about the active-active. So we know that the multi-site is working on the asynchronous replication. So how do you handle this data difference between 2 different sites?
So we are in the active-active world, but the way we are currently is we sit, so there sits an HA proxy in front of us, and all our HA proxy currently only routes to one data center, and the other data center is more like a passive for us. So all of the requests for us always goes to the primary side. So that's how we kind of achieve, like, so there are issues, there have been issues that we have found out where, as the gentleman pointed out, like if you write to the primary and then if the subsequent read to the secondary would result into 404, so we don't want to fall into that particular category. So what we do ensure is we are always serving all of the client traffic only from one single data center. And the other guy is only as a passive guy there, which does the replication. Technically, it is active-passive, but we are still in the active-active mode, yeah. Sure, yeah. Our legacy clusters are still at Nautilus. Right. Reef. Yeah. So we have our legacy cluster as it is. These are our new clusters that we have set up on the Reef, yeah.
So what is your experience of once you upgraded to Reef with dynamic quality sharing on multi-site? So with the existing buckets, did you have any issues with it? Or only the buckets that have been newly created were working fine?
So a slight confusion here. So our legacy clusters still exist. We did not upgrade our legacy clusters. This was kind of more like building up new multi-site clusters, and then, yeah.
Before the migration into test?
Yes.
So another question would be, if you did same test with Nautilus 1, so you didn't have any missing objects in this?
On the primary and secondary, that's correct. Right. Oh, sure. Sorry, yeah, sorry, yeah. Right, our basic is 4K objects, yeah. No. That's correct. Yep, so we did find issues with the active-active in terms of multi-part upload, where the multi-part upload was going to the other side and then it couldn't find the other upload IDs and signals. So that was one of the issues that we observed in the active-active, and that also kind of changed our way we wanted to go about. So basically we kind of hide the secondary side underneath the BDNS entries and then just route all our traffic to the primary. We tried, so our focus was more because we wanted to stay on the production side, like we wanted to mimic what our production workload would be, and so we just tested on that front, yeah, basically. Yeah, it's not tested though, yeah, that's right. Yeah. Thank you. Looking forward to meet you all, and if you all have any questions, we are there here for next 2 days. Please feel free to reach out to us. Thank you, everyone.